Hey programmers, Alvin here. Right now I want to go over a Python solution for this leaf list problem. So I'll jump right in. Hopefully you watched the approach video and we said the key to victory here might be our depth first traversal. So I'll start by showing you how you can do this iteratively, which of course means we should initialize our stack data structure. I'll go ahead and throw the root on it. And if I look at the problem, we can't really assume that the input tree is going to be non-empty. If we look at this example 04, sometimes they'll give us none as the root. And so what we'll want to do is actually guard with that up front. So, hey, if my root is none, then I need to return all of the leaves of that empty tree for which there are no leaves. So that would just mean returning an empty list. Nice. So now I can start my general code for just my classic depth first. So while my stack is not empty, a single iteration of depth first should just remove the top of your stack. So for me, that's stack.pop. And I'll save that as my current, like I always do. So that's an instance of node. Nice. Let me just lay the foundation of doing the correct traversal. So I'm going to check if my children exist. And if they do, I add them to the top of my stack. So if current dot left is not none, then I'll push left to the stack. So stack dot push current left. And it's just going to be about the same for the right hand child. Something like this. One thing I need to be sure to do though is for this depth first traversal, and like they say in the problem, it's super important that your output is in left to right order, right? So if I look at the example, I want D, E, F. And so although I'm doing a depth first traversal, I also need to guarantee that it travels left before right. And if I want to do that, then I actually should flip the order of these. If I write it like this, I'm pushing the right child on the top of the stack and then the left child. That means the left child's at the top and they'd be explored first on the next iteration of this while loop. So that should give me my left to right preference. And then from there, I think I just need to construct the output now. So typically whenever I write, my iterative traversal code for trees, I'm going to process the node whenever it leaves the stack. So when something leaves, I'll actually check if it's a leaf at that point. So maybe I'll create a collection of leaves that I'm going to return at the end. So I'll return down here. And when something leaves the stack, I just check, all right, is this current node a leaf? Very easy to check, right? If current dot left is none and current dot right is none, then I'll go ahead and add that value to the leaves list. So leaves dot append current dot val. Nice. So that's looking pretty good. Let's go ahead and give this a test run. Nothing too fancy here. Maybe the most difficult part of this problem is really just deciding between your breadth first or your depth first. So here I'm getting an error. List object has no attribute push because I'm in JavaScript mode right now. It's always tough switching between languages, right? Hopefully you feel my pain in that regard. Trying to make video walkthroughs for every different language we support here, so bear with me. So we'll use append instead. Nice, and there we have a solution that's iterative for this leaf list problem. So this code's definitely going to run in O of n time, right? Popping from the top of a stack and also appending is definitely O of 1, but total number of iterations in our while loop is going to be n, right? Because every node enters the stack once and leaves the stack once as well. All right, so I'll tell you what. For completeness, why don't I show you how to solve this one also recursively. Nice. So your recursive code might look something like this. I would still create a collection of leaves to gather everything into. And I would actually create a helper function to do the actual recursion. So I'll call it underscore leaf list. It's going to take in the root, but it's also going to take in this collection of leaves by reference. So I actually want this recursive helper function to mutate and add elements into the existing leaves list. So my top level call over here might look something like invoking my leaf list function, passing the original root, and also a reference to the leaves, right, that I want to fill up. And then after that function runs, hopefully I can just return leaves. So now I just focus on building a depth first traversal, right? And I need to also make sure it travels left to right, so I'm always going to bear that in mind. But for now, base case for our recursive code is always about the empty tree. In other words, when our root is null. So if root is none, then I should just return, right? I don't want this function to actually return any data. I just want it to mutate leaves, so returning nothing over here is okay for me. But in the recursive case, I know I must do a call to the same function upon root.left, passing in the same leaves collection. Same thing for root.right. Now if I do a quick spot check at this point, because now I'm writing this in like the recursive way, this code would travel to left children before right children. It would only get to line 17 if it already returned from line 16, of course, right? So no tricks here. But as I do all of that, maybe after I check if the root is none, and before I make my recursive call, I need to check if like this node right now is actually a leaf. Then I would add it to the leaves collection. So if root.left is none and root.right is none, then I can just do leaves.append root.val. Nice. So if this thing is a leaf, then I can go ahead and just add it into our leaves collection. You might wonder, it is the case that when this condition is true, I would add that leaf into my leaves collection, and that would actually call on its left and right, but they might actually be none, right? But that's okay because when I actually evaluate those calls, I would just exit anyway over here, right? So for the most part, you're always going to need in your depth first recursive code, you're always going to need to catch the case where you have root as none. And that's because you need a way to actually satisfy nodes that only have one of their children, right? So what you won't be able to do is just ever omit code like that. So if I run that, that should fail, right? And even if you were like, oh, well, if something's a leaf, then it has no left and right children, so just return, right? This code, I believe, would also still fail. Let me actually bring this up for you so you can see it. My head's probably in the way. So although my base case catches if my root is a leaf, then just return, that won't satisfy a node like this one, like the C node, right? It has no left children. And that's why I like to write always that classic base case of if the root is none, then just return. So this might be the final form of our code. Either way you slice it and dice it, I think a depth first is the way to go. Definitely practice both the iterative and recursive before you hop into the next problem. See you there.